Hi everyone, this is test 2 of the MEV device, if you want to call it that. What I'm doing is keeping the RPM fixed. So here, as I said in the previous video, we have a 5 ohm load, and this is being used as a generator. And I've modified the other motor to be a motor, and actually I'm using two gen outputs. So basically, one with the brushes at 12 o'clock position and one with the brushes at the 9 o'clock position. So basically my positive is at the 3 o'clock position and the negative input is at the 6 o'clock position. So that's a 4-brush motor, and this is basically now just a 2-brush motor because I'm just using 2 of the field coils in, or the magnet fields in this one here to output pretty well 10 volts across that resistor there, and that's a 5 ohm. So there is the data right there on the scope, somewhere well between 9 and 9.5 volts there, so close to 20 watts. That's not important. This is just to create a load for the motor to test this under load. And I think that's where it's important to find true data. So we are not changing this load, it's a very fixed, so this has to deliver a certain amount of torque, and if it can maintain torque at a certain RPM, then we have a good valid results. So here I added two 10,000 microfarad capacitors. I'll zoom in there. So you can see they're 50 volt, 10,000 microfarad each to filter the DC to really flat. And I have each on there a 1 ohm resistor. So those are the new loads for the device there. This is on the scope, and this is on the meter. Because of common ground problems, I can't have both of these loads on the scope. And what we're going to be looking at is basically this here. We're delivering 13.8 volts at 3 amps, 3.41 amps, okay? And that is the power supply right there. But what we're using is this meter here as for very accurate data, because I've got more resolution on this meter here. And so that is what we are putting in to the motor to drive this load here, and at 1500 RPM. Alright, so that is the constant RPM that I'll maintain. And we'll next put these here on generator outputs of this drive motor. So basically, if we look at that data, we're going to be doing a fixed load test at 1500 RPM. So we're not having the gen coils on, taking 13.8 volts at 3.41 amps equals 47 watts. 47 watts is being put into the device at this time. So now I'm going to hook up each one of these gen outputs on the motor. There's one, and you can obviously hear an increase in RPM. And there is the second one now I'll hook up. So again, you hear another increase. So to make a comparable test, what we have to do now is we have to drop down the RPM, because now it's much higher. So we're at 1648. So I'm going to just readjust the input voltage, drop that back down to the 1500 RPM range. So here we are at 1500, over 1500. And if we look at our data, 12.65 volts at 3.5 amps basically. And I had already previously calculated that, so with the gens, 12.66, that's what I had there at 3.51, basically 44 watts output. So the motor is now running more efficiently and for less power to deliver the same amount of power on this load, because obviously our RPM is the same. And if we look at our scope data, that is the delivery on the load there, so pretty well again at our 9 volts. And this here is what's across that 1 ohm resistor. So 1.16 volts is over 1 watt here, and on this meter here we have about 1.6 volts, 0.96, so very close to 1, let's call it 1 volt per resistor. So basically 1 volt per resistor is, we have 2 watts here that we're outputting at the same time, making this more efficient to drive it at the same RPM. That is basically what you need to look at, and that would be the correct power calculations for figuring out the efficiency of this, utilizing these generator coils. So I hope this test meets everybody's criteria, and thanks for watching. Bye now.